from a 60-meter tall platform. That's the 60 here. The equation of the ball's height in meters at time t seconds is given by this equation. How long until it hits the ground? So we've talked at length that hitting the ground means setting the function equal to 0.
Yep.
And if we can, we'd like to factor it. This one does not factor well, so we do have to use the quadratic formula for that. So can you give me the values of A, B, and C in the quadratic formula?
A is negative 4.9, B
Okay,
is
very good.
20, and C is 60.
Good. All right. Now I mentioned I really like using this Desmos scientific calculator. You do not have to use it, but you do have to get the values into this equation, plus or minus the square root of b squared minus 4ac all over 2a. So question, I guess, is do you want, what are you going to use for a calculator today? And
Just a generic Apple calculator.
okay, that's going to really work against you here.
Oh,
But that's okay. You got to get the part under the square root correct. So why don't you try working that out on your calculator there? It's 20 squared minus 4 times minus 4.9 times 60, like that. So go ahead and work that out for me, please.
Okay. 776. That's what I got.
Okay, so that's again, that's where the issue with using this, whatever you're using there, which I can't really tell. Yeah, that is not the correct answer. So the way to do this, you got to be very careful with the signs here. Like you almost want to pre-calculate the fact that this becomes a plus if you're going to use that tool. 4 times 4.9 times 60. Okay.
Right.
So I would still recommend going to using something different than that, but I'll leave that up to you for at least for the time being.
What my mistake was. I always like get so confused with negatives and positive signs, and it's like that's my fault. I was supposed to add them.
Yes, and that's the difference here. Can you give me the new value, please?
Yeah, just give me a second. Like 1,576.
Yes, that is correct. So that's the part under the root, minus 20 plus or minus the square root of 1,576 all over 2 times minus 4.9. So this is, again, this is kind of a tough calculation to do, and especially if you're doing it, kind of like one at a time. So you really want to find a tool that allows you to do this all together. A lot of students are using like a TI 83, 84. You don't necessarily need that, but you need something with the ability to enter like a full expression in like this. So I, again, would strongly recommend using that Desmos scientific. The reason is, let me just show you this here. I can enter it exactly the way that it's written. I'm going to show you that here by snipping this in. I can go right to the tool, enter it like this. A little bit of a learning curve, right? You got to know how to get the fraction bar, you got to get the square root, but I can enter it just like this and it will provide the answer. So if you don't want to do that's fine, but go ahead and I guess try calculating the plus one of this and let me know what you come up with.
Okay. The 1,576 would still be in the square root. So
yes.
And so on the bottom, like for the denominator, it would be negative 9.8.
Yes.
So what? So it would be x equals negative 20 plus the square root of 1,576 over negative 9.8.
Yes.
Okay, that's what I got. So that's good. And then for the subtraction version, it would be the same thing, just with a minus.
Yes. Yes. Yes.
Okay. Alrighty. Got them both written down. Those are our answers, right?
Well, you got to get the numerical values. That's what I'm at. That's what I'm getting you to kind of. I'm kind of waiting on you to tell me, okay, Matthew, for the plus one, it's this number. For the negative one, it's this number.
Yeah. So I don't know what to do from here because I have the denominator figured out, and then for the
Right.
numerator, it's just looking
Right.
for the
So let's try this here. Let's try this. I'm going to send you a link to the Desmos Scientific again. If you can't tell, I'm strongly trying to get you to use something better than what you're currently using. And I will do the same. So I'll share that screen, okay, as well. But I really want you to try. Want you to enter this with me as we go. So let me new share that, because we're going to need to do this on every problem we're doing today, and we might need it for other problems. So it's not like we're going to lose. Not like we're going to lose time by doing it this way, but we got to get it down here. So let me copy this. All right, there it is. Okay, new share. Okay, so do you see this window that I've
yes.
got up? Okay, so you've got to be able to find the fraction bar. There's the fraction bar there, okay?
Mhm.
And then it's minus 20 plus the square root is over here on the left, 1576. And on the bottom, you can enter the minus 9.8, or you can times minus 4.9 by 2. Okay, so do you see this? And then have you entered it? And do you have the same value that I've got here?
Yes.
Okay, so all I want you to do is change this plus to a minus and tell me the new value.
It would be 6.09.
That sounds correct. Yes, 6.0. Perfect. Okay, so that's why I wanted you to see how nice that is. So there are two answers here. The first one is the negative t equals the negative 2.01, and then 6.09 for the other one. So which do we want? Which is the most reasonable answer here? Well, how long before the ball hits the ground? Can it be negative?
And no.
So it must be the second one.
Yeah.
So that's the answer they're looking for there. Is that okay? Clear?
Yeah, that makes
All
more
right.
sense.
All right. So let's go to number 9 here and take a look at number 9. Now I'm going to help you set these up. I'm just really want your help on the calculations for sure. Let's take a look here. A rectangle and a square have the same area. Okay, so here's a rectangle on the left.
Wait, are we on number 8?
Sure, we can go back to 8 here.
Yeah. Because we did 7. We left off at 7, and we didn't just do number 9.
Okay, so number 8 here is asking for the maximum height of the ball. So it's the exact same equation that we we're just looking at, but now it's the maximum height of the ball. So again, this thing goes up and it comes down. We want what's called the vertex there. So the vertex has two components. It's got an X and a Y value. Okay. The max height here is the Y value. So we want the Y value of the vertex. So one option would actually be to graph this, but since you need to show your work, we're going to do it by hand. There's formulas here to find the X coordinate of the vertex. It's minus B over 2A. All right. From before, you know that the B value is 20 and the A value is minus 4.9. Will you calculate that for us, please? The minus b over 2a.
Mhm. That would be -20, like over -9.8.
That's right. But the calculator can do all of that for you. Like you don't have to pre-calculate anything. The Desmos will, you just enter it -20, or the fraction bar -20 on the top, 2 times minus 4.9 on the bottom, and you'll get that result. You don't have to do any pre-calculation.
Yeah, I didn't use a calculator. I just looked up on my for the 9.8, so I didn't have
Yes, good. So what, give me the answer around to like 2 decimal places.
decimal places, so it would be. Oh dear Lord, I hate decimal sometimes. It's either the hundreds or the thousands.
I just want the x value of the vertex. So give it to me to 2 decimal places here.
Okay, I'm confused still. I'm sorry.
What number do you see for the result of this?
Well, -20 over -9.8, obviously. So it would be.
Okay, and what is that when you go to a calculator?
All right, I'll try Desmos for this.
Okay.
So I put -20 over -9.8 in the calculator.
Okay.
It would be 2.04.
Very good. Okay. And I'm just going to go out 2 more decimal places just in case we need it for the time being. So that's the x coordinate of the vertex. The y coordinate, you get the y coordinate from putting this x value back in for t. Okay. So the way this works is they're telling you the height as a function of time is minus 4.9 t squared plus 20t plus 60. And you're going to put in this value in for t. So we can go 2.04, that's fine. Minus 4.9 times 2.04 squared plus 20 times 2.04 plus 60. And again, if you go to that calculator, you can enter it exactly the way you see here. You know, no issues with that. You just have to enter it in that order with the parentheses and all that, and it will give you the answer that you're looking for.
Mm-hmm.
So I'm going to do that. I'm going to do that here as well. And we'll compare answers here.
Yeah. I got 80.408.
I agree. So we'll say 80.41, and then let's go up to the units here, meters. That is the maximum height.
Mm-hmm. Oh wow, you're right. Desmos is easy. The
All
more.
right. So yeah, and it's just, just something worth trying. I'm not affiliated with them. I don't get anything from it. I just think it's a good tool to use.
Mhm.
All right, let me know when you're ready for us to move on to number 9.
Yeah, I'm ready.
All right, number 9 here. All right, so a rectangle and a square have the same area. So here's a rectangle on the left and a square on the right, okay? The length of the rectangle, which we'll call this down here the bottom, the length, is 70 feet more than 2 times the width. So here's the width. So let's call the width x, okay? 70 feet more than, what math operation is the word more?
Um, Adding.
Adding, okay? How about 2 times? What's that math operation?
That's multiplying.
So 2x plus 70 is the length, okay? And it says here the length of a side of the square is 30. So they're saying this is 30. And because it's a square, because all sides are congruent, the the width is also 30.
Mm-hmm.
Okay. Now we know that the areas are the same.
Right.
See where it says the same area? So we're going to calculate the area of the rectangle. The area of the rectangle is base times height. It's the length times the width, base times height, if you will. That's 2x plus 70 times x. And the area of the square, well, it's base times height. It's 30 times 30.
Mm-hmm.
So on the left here, how can we simplify what's on the left? What can we do with this x on the outside?
Um, I would, well, maybe you could multiply it into the parentheses.
Exactly. So that's 2x squared plus 70x. And on the right, 30 times 30 is 900. Okay.
Mm-hmm. 30 times 30 is 900, yeah. Okay.
Okay. Now very importantly, what did it say from the very beginning about the area?
They both have the same area.
So what can we do with these two quantities?
Hmm.
This is the
Well,
area of the rectangle. This is the area of the square.
so we can keep the area of the square the exact same, maybe.
Okay.
As for the rectangle, because of our x's, we don't know what they
But what
are.
do we, but this quantity represents the area of the rectangle and this represents the area of the square. And what do we know about these two that we just said from
Same
the beginning?
area. They both have the same area.
They're equal. They're equal. You can set them equal to each other.
Mhm. Makes sense that I have to use the calculator again. No, wait, no, I don't.
So we're setting them there. We're setting these equal because it says in the problem, it says they have the same area.
Right.
Okay. This is the area of the one on the left, the area of the one on the right, and they're equal. This is a quadratic. So we know how to solve this. We can subtract 900 from both sides.
Mhm.
And now you've got 2x squared plus 70x minus 900 equals 0.
Mhm.
Now we could factor this. I actually don't know if it factors nicely. Why don't we just use quadratic formula here?
All right, sounds good to me.
So A is 2, B is 70, C is minus 900.
Mhm.
Okay. Apologize if you heard that. That was a dog snoring.
I didn't hear anything.
Okay, okay, good. I can't tell if he's too close or not. All right, so the x value here is minus b plus or minus the square root of b squared minus 4ac all over 2a. So for you, the way this is going to look, it's minus 70 plus or minus the square root of 70 squared minus 4 times 2 times minus 900 all over 2 times 2.
Mhm.
Do you want to try entering this into the calculator for us, please?
Yeah, just give me a second. I'm gonna do something. Yeah, now I'll put this into Desmos real quick.
Cool. I'm doing the same, so we'll compare results.
All right. Okay. I wrote down like the whole fraction with the whole quadratic, like everything together, and the answer just says undefined. So
Okay. So that's just maybe not entering it quite correctly here. So let me show you again how to do that, and that's okay. That's part of this kind of learning journey that we're on here. So let me make sure I know what you're seeing. You're seeing that. That's not what I wanted to show. Sorry, I got too many things open. There we go. So here we go. The way to enter this is to start with the fraction bar. Okay.
so that's what I did.
And then minus 70 plus. So you don't enter the plus or the minus. You have to choose one. The square root 70 squared minus 4 parentheses 2 parentheses minus 900. Does this look similar to what you have?
Yeah, I just have to rewrite it again real quick.
Okay.
Yeah. Yep, that's what I have right now.
Okay, so what goes on the bottom?
2 times,
Top.
well, 4 actually, but almost just 2
So,
times.
yeah, so get in the habit of not trying to calculate it as you go. Let the calculator do the work. What's the final answer when you put that 4 on the bottom?
I got 10. Like,
Yeah,
wow.
that's the correct answer. Good. Okay, let's go back to the other screen. All right, so yeah, the correct answer is 10. Now let's go make sense, sure that makes sense physically in the problem here. So let's go back and look.
Mhm.
That means the width of this rectangle is 10. That's the X value. What is 2 times 10 plus 70?
2 times 10 is 20, plus 70 is 90.
So question to you is 10 times 90, 900?
Yes.
Yes, it is. And we found the correct answer. Okay, so we want the dimensions of the rectangle. You want to say that the width is 10 feet, got to include dimensions, and the length is 90 feet.
Mhm.
So it's not good enough just to give the X value. You have to give the X value and the other dimension there.
Mhm. Got it.
Let me know if you need to get any more of this down. Otherwise, I'll move on to the next question here.
Well, I'm ready for number 10.
Great. All right, number 10. Again, these application problems, they just take a lot longer. Others should see a little bit faster speed on the rest of this course here. All right, so I know there's a lot of words here, but we want to look at this equation right here, okay? And we're interested in minimizing the cost. So this thing graphically looks like this. So there's a point right there that minimizes the cost. Do you remember what this point is also called in a quadratic?
No, I don't. Wait.
So the vertex refers to either the min or the max.
Mhm.
So we're looking for the vertex. In the last problem, guess what we were looking for? Well, this one up here. What was this called?
We're looking for the maximum height.
Right, which is the vertex. The vertex. So the vertex comes with formulas. So your formulas for finding the vertex, x equals minus b over 2a. So you have to look back at this quadratic equation right here and figure out the a, b, and c values. A is 0.04, b is minus 8.504, and c is, which we don't need, but we'll write it anyway. I'd like you to calculate this for us, please.
All right.
the minus b over 2a.
I'm moving the calculator real quick, so sorry I'm taking so long.
Oh, take your time. I think it's so important that you get this down because you're going to find that this tool will be useful for you on other questions when I'm not around. And you just maybe get ahead here by learning this.
Yeah. Okay, so I got the answer.
Okay, what do you got for me?
I got negative 10.63.
And you're using these values, right?
Yes.
Okay. So there's a mistake in what you told me. Did you use the Desmos?
Yes.
Okay. You put in the numerator minus parentheses minus 8.504.
Oh,
And
I
then
made a mistake. I found it. Hold on.
and then 2 times 0.04 on the bottom.
Now it's negative 106.3.
So check what you've got compared to what's written here. You have either an extra negative or a missing negative.
I think I have a missing negative.
So the B is the B, whatever it is, and you always negate it. So if it happens to be negative, you're just negating a negative.
There we go. I fixed it. It's actually positive 106.3.
Yes, very good. All right, now that's the X value of the vertex. We want the Y value of the vertex. To get the Y value, you have to take this X value and put it back into the equation there. Okay, so here's how that looks. Just going to kind of reset the screen here. The cost as a function of X is 0.04 X squared minus 8.504 X plus 25302. You're going to put this 106.3 in for X, 0.04 times 106.3 squared minus 8.504 times 106.3 plus 25302.
I'm just writing it down. I'll put
Yes, it is a lot there. So
that's a mouthful.
it sure is.
Yep. I'm gonna go put this in the calculator. There's no. I got an answer.
Yes, it's a large number.
Yeah, it's wow, that is a lot. It's like 24,847.406.
Good. Okay. Yeah, that's fine. So 2,400. Let's go 86 just for some rounding stuff, and that would be in dollars.
Oh my God, this person is rich. Right? I wrote down the dollar sign for that.
And this is, just to be clear here, this is dollars per 1,000 units based on the way the problem is written. That's a little subtlety, but let's just go with that. All right, let's look at your next lesson here for today. Let's make some progress on this. All right. So number one here, doing some quadratic inequalities. Stop and think. Okay, stop and think. All right.
I'm getting the hang of this Desmond's calculator.
Yeah, I think you'll like it, and we'll spend some time graphing as needed as well, just to get you more comfortable with that, because you're going to use it not just in this course, but in others, really. All
Yeah.
right. Find the zeros that would be marked on the number line for this inequality. So forget about the inequality for a moment. If I asked you to figure out where this equals 0, and this is a type of factoring you would have seen, what is the result?
Well, it would be the 0 that's on the right, I think.
So this is called difference of squares. Have you
Oh
heard of
my
that
God.
before?
Yeah, I have like last year. It's so yeah.
Yes, it's far away. So I'm going to help here. It's x minus 3x plus 3 equals 0. Do you remember what to do from this point?
Yes. You can either like what we did on the last two problems, do like the x minus 3 equals 0 and x plus 3 equals 0.
Exactly.
Don't want to go back to where we started with the x squared minus 9.
Okay. So this ends up being, I wrote that poorly. X plus 3 equals 0. What are the two x values?
X is 3 or x is negative 3.
Good. Okay, so here's the number line. And I don't spend much time making those number lines. I just put the points there. You don't have to have 0, but it wants to know where they would be marked on the number line. There it is.
I think when I first did these, I think I had to do them with the number line.
You're welcome to add as many places as you want on there. You really would want to even go out and grab like number grid paper and.
I'm right now writing with graph paper.
Oh, nice.
Yeah,
Awesome.
because it keeps my work like neat. Okay, perfect. I got it. All right. Is there anything else we need to do?
That's it for number 1. So for number 2, we are going to take the same number line, okay, and we're going to figure out how it applies to the original function here. So we were interested in where the original function x squared minus 9 is less than 0. Okay. So there's a couple of ways to do this. One is to test points. So we're going to test points. We want to choose something in each region. So something less than -3, like -4, for example, something between -3 and 3, like 0, and then something to the right of 3, maybe like 5.
All right.
And we're going to put these values into x squared minus 9. We're going to test these in x squared minus 9. Which one do you want us to try first?
Well, let's do -4.
Okay, so -4 squared minus 9. You envision putting -4 in for x. So that would be -4 squared minus 9. What does that become?
16 minus 9 is 7.
It's 7, or what we care about, it's positive.
Yes, positive.
Okay. Now do the same thing for 0. Put 0 in for x.
It would just be -9.
And we only care about the sign, so I'm going to put a negative there. How about 5?
Okay, so 25 minus 9 would be 16.
Or positive.
Yeah, positive.
So we want, though, what we're interested in is where it is less than 0. So do you see that it is less than 0 between -3 and 3?
Yes.
So that is our answer. Our answer is all the numbers from -3 to 3. Now, how to write the answer? It's interval notation, but it's -3, comma 3. This is the answer that they're looking for. Like everything you just did leads to what goes inside this box.
All right, I wrote it down. Sorry,
Awesome.
no problem.
Okay, for number 3, it's basically restarting what we did in number 1, but for a new problem. So let me snip that in and we'll take a look here. So the first step here is to factor the x squared plus 2x minus 8. So this time you're looking for two numbers that multiply to minus 8. That's the first condition. The second condition is that they have to add to positive 2. Do you remember doing this from Algebra 1?
Kind of.
Kind of. Okay. So let me help you out here. 1 times negative 8, does that multiply? Do these two numbers multiply to negative 8?
Yes.
Good. But do they add to positive 2?
No.
So that's not the right ones. How about negative 1 and 8? Does that work?
Yes, but can they add to positive 2? No.
No. So how about 2 and negative 4?
Yes.
Yes
And
to the first, but
no to the
so
second.
notice we switch the signs.
Then
And
it
now,
would be
so there's your answer. It's x minus 2, x plus 4. Now let's just set these equal to 0 for the moment. Can you tell me those two x values?
sorry, can you repeat that?
I'm asking for the two x values that make this 0.
Okay.
And you're going to set each of these factors equal to 0.
So x minus 2 equals 0, x plus 4 equals 0.
Okay.
X equals 2, and x equals negative 4.
Very good. Okay. Those are the values that go on the number line here.
All right.
Negative 4 and 2. Is my audio okay, or are you having issues hearing me?
No, it's okay. I just sometimes get questions.
Okay. Okay, and I want to make sure I'm got a stable connection too, because that's the value of this. All right, so make your number line, take as much time as you need, but get those down. We're going to use it to answer the rest of the question.
All right. While you were telling me that I got the number line written down. So
Awesome, you're fast, good. So now we're going to test points in each of the regions.
Okay.
What points should we test? Give me your test points here, one in each region.
So besides 0, let's try for the negatives. I want to try negative. Let's do negative 5.
Okay,
And then for the positives, let's try 3 actually.
great. You just have to be to the right or to the left. Now you are going to try them back in either the original or the factored form, whichever one you want.
I want to do the factored one.
Okay, so go ahead and try negative 5 and let me know what you come up with, please.
Mhm. So for I got 7 when I did that.
So positive,
The
okay,
positive 7. Sorry, I forgot to add that. So 1 positive.
and how about for the middle one?
Okay, just a second. I got negative 8.
Okay, negative there in the middle, and for the last one?
Okay, I got 7 again.
Okay, positive, good. Now, we're interested, if you go back to the original problem, we're interested where it is less than or equal to 0, okay? So basically wherever it's negative. But this time it also includes the endpoints.
Mhm.
Okay, so the full answer here is -4 to 2, but because it includes the endpoints, we use this symbol right there, the bracket.
The bracket.
All right, so just a quick thing here in terms of what goes together, because there's sometimes some confusion. If you see this symbol, filled in bubble, bracket, bracket, these all go together, meaning that they're all related.
Yeah, I know that for the greater than or equal to or less than or equal to, the closed bubble is, yeah, I remember these.
Okay, and then for the other one, there's a couple more symbols that you might want to memorize or have down. It's the less than, the greater than, the open circle, parenthesis, parenthesis, infinity, and minus infinity.
Yeah, infinity can be negative.
Yes. So these all go together.
Mhm.
All right, let's go to number 4.
Right.
Oh, I'm sorry. We did number 4. Let me try to figure out where to put that in the answer. So
Number 3.
number 4 starts kind of right there. Like after you factor it, everything below that is for number 4.
So okay, so I have to put number 4 down where the number line starts.
Yes, essentially, yeah.
Okay. Okay, perfect. I had to box the one of my answers. I went for okay. I got it. We got it. So I'm good.
Okay, move on to number 5. Nice thing about 5 and 6 is they're really similar to the ones we've just done.
Yeah.
So number 5 here, you're going to first factor this thing. You're going to factor x squared minus 7x plus 12. So you're looking for two numbers that multiply to 12, but then add to minus 7.
Okay.
So multiply to the last number, but add to the middle number.
So,
Any,
so what I'm thinking could work for 12. It would be -4 and -3.
you are correct. And that's what you write here. You write x minus 4, x minus 3, and you set it equal to 0.
That would be x is 4 and 3. That's it.
Good. So on the number line here, they're right next to each other. You can obviously squeeze them in a little closer, but for what we're doing, I'm going to keep them spread apart for kind of illustrating what we're doing here. The next thing is test points, right? So you're going to test something here, here, and here. So 3.5 in the middle,
Sure.
0, and I'll just suggest 5 here.
Okay.
But I'd like you to test those points and tell me where or what the sign is.
Mm-hmm. 4. Okay, for the 0 minus 4 and 0 minus 3, I got 12, positive 12.
Okay.
So positive. Okay, and then for the 3.5, I got negative a 0.25.
Okay, it is negative, I agree.
And then for the 5, I got positive 2.
Good.
The pattern for these number lines, it's always going to be positive, negative, positive, unless something happens.
Until it's different, right? So math is full of exceptions. And if we were in calculus, I would definitely have emphasized that. Would you like to know why this one follows this pattern? Would you like to know the kind of the shortcut for this?
Yeah, I do. I'm actually quite curious.
Okay, so let me grab, and I got to make a different pen here. I usually do this in green. So here's why. The graph of x squared minus 7x plus 12 looks like this.
Yeah.
So this plus indicates where it's above the x-axis. The minus indicates where it's below the x-axis, and this other plus is where it's above the x-axis.
Mm-hmm.
And that is the reason.
That makes so much sense.
Yep. So that's your shortcut. Now, I don't know if your teacher will allow that, or they'll feel like you're not showing your work, but that is why. That's what I show in calculus. But yeah, this is it. So in terms of your answer, though, less than or equal to 0 is everything where it's negative.
Yep.
Does it include the endpoints?
I think so. Yeah.
It does. So this one is bracket 3 to 4.
That's so cool.
All right, so I'm going to quickly do this number 6, and then we're going to close out for today. So x squared minus 64 is a difference of squares. It's 0 at 8 and negative 8. Your number line is negative 8 and 8. Your test points could be negative 10, 0, and 10. But it will be positive, negative, positive. And the answer you're looking for here for where it's greater than 0 this time is on the outside. And this one we'll have to maybe spend some time talking about next time, but it's minus infinity. It's minus infinity to minus 10, union 10 to infinity. So if none of that made sense, get it down. We'll pick up here tomorrow and keep working on it for next time.
Okay.
All right, I'm going to go ahead and stop the recording right here.